Let us first understand the term. The term is temperature inversion. The term inversion indicates that something normal is getting inverted upside down. Something was like this, and then when it becomes like this, it is called as inversion. Now, the term temperature inversion indicates that normal temperature pattern in the troposphere is getting turned upside down. So in order to understand what is temperature inversion, it is important that we understand what is the normal temperature pattern in troposphere. Sun emits radiations which are called electromagnetic radiations, and they enter the earth after passing from the ozone layer, right? So we think that these sun rays heat up the atmosphere, and that is how temperature of the earth is maintained. If you have studied geography, then you know that it is incorrect. Why it is incorrect? Because atmosphere cannot absorb radiations which are coming from the sun. Why atmosphere cannot absorb these radiations which are coming from the sun? Because these radiations are short wave radiations. Okay. The atmospheric components that we just talked about are actually opaque, meaning they allow these radiations to pass unhindered. Hence, they pass from the atmosphere and hit the ground without getting absorbed in the atmosphere. I hope you understood this. Now, then how is this atmosphere heated? How the temperature of the earth is maintained? The normal average temperature of the earth is around 15 to 18 degrees centigrade. How this normal average temperature of the atmosphere is maintained? Here is the answer for that. Normally what happens? Sun rays hit the surface of the earth, and these rays which are coming from the sun after passing from the ozone layer are safe, and they are short wave radiations. If you have studied electromagnetic spectrum, then you will understand what are short wave radiation. These are the radiations which have high frequency or low wavelength. Fine. So these are short wave radiations. They pass through the atmosphere unhindered, and they are absorbed by the surface of the earth. Once the earth is heated by absorbing the short wave radiations from the sun, earth starts emitting radiations back. So the radiations which earth emits back, they are long wave radiations. So these are the sun rays which are coming and hitting the surface of the earth. The surface of the earth absorbs these radiations, and after that it releases radiations in the form of long waves. What do I mean by long waves? Long wave radiations are those radiations which have long wavelength. For example, infrared radiations. Now, what is the beauty of these infrared radiations? Infrared radiations are absorbed by the atmosphere. So, atmosphere is efficient in absorbing long wave radiations. In the previous slide, I told you that when these rays are coming from the sun, atmosphere doesn't absorb them, right? Why? Because these radiations are short wave radiations. But when the earth is emitting back these radiations, these are long wave radiations, and atmosphere is very good at absorbing these long wave radiations. So what is the conclusion can we draw from this explanation? One important conclusion that we draw is the atmosphere is heated bottom up, not top to bottom. So this is a misconception. This is the reality. If you have understood this, then it is easy to understand what is the normal temperature distribution in the first layer of the atmosphere, that is troposphere. Now, let us understand what is conduction. Conduction is a process of transferring heat from one body to another body through direct contact. This is the surface of the earth. It has absorbed the shortwave radiations from the sun and has heated up, right? Now it is warm. It is warm compared to this layer of the air. Okay, on the earth, you have these layers of air, right? Now, this layer of air, which is blowing on the surface of the earth, gets in touch with the surface of the earth, and this surface of the earth transfers its warmth to this layer of air. And this process of transfer of heat from the surface of the earth to the top layer of the air which is touching this surface is called as conduction. And once this layer warms up, it starts to expand. Now, you must have studied this in science that whenever air is heated, it expands. You got this? So first, air gets heated because of conduction. Once the air is heated because of conduction, it starts to expand. Then, once it expands, tell me what happens to the weight. Now, when it is expanding, its volume is increasing, right? The volume of air is increasing. When the volume increases, then it becomes lighter. Point. When the air becomes lighter, it starts moving up, right? Whenever something becomes lighter, it means that the gravitational force on that object decreases and that object can easily go up. So the first method through which heat transferred in the atmosphere was conduction, and conduction happens through contact. Once the heat is transferred to that layer, it expands and becomes lighter and starts going up. And this way of going up is called as convection, right? As this warm air starts going up, now in the first slide I told you that atmosphere gets heated up bottom up. It means that the layers which are at the bottom have high temperature because they are receiving heat from the earth, and the layers which are higher up are less warm because they are away from the source of heat. So as this air moves up, right, it loses heat and becomes cooler and cooler as it moves up. So that is what normal distribution of temperature in troposphere is. This is the layer of troposphere. For example, let's say this is tropopause. Then what happens here? As you go up, temperature of the air decreases, right? Temperature of this air is highest. As this air starts moving up, temperature keeps on falling. And if you reach the tropopause, the temperature at tropopause is minus 50 degrees to minus 80 degrees centigrade, meaning from 30 to 40 degrees centigrade at the surface, the air drops temperature to almost minus 50 to minus 80 degree temperatures when it reaches the tropopause, right? So this fall in temperature as the air moves up is called as normal lapse rate. And this is called as normal distribution of temperature. Now, this normal distribution of temperature is very important for one important reason. That is, whatever pollutants we are generating, because of this normal distribution of temperature, these pollutants are taken higher up the atmosphere, as we just studied, because of convection. Convection, why the convection is happening? Because the lower layers are getting heated up from the Earth's surface and air is becoming lighter and going up, right? And it reaches a particular point, that is tropopause, and this air is pushed towards the side because now it has become heavier because it has become cooler. As it moves sideways, these pollutions which were created at one place are carried to other places because of this wind. This is how pollutants are spread across the world because of this type of temperature distribution. Got it? So normal distribution of temperature is very important for scattering of pollutants from one place to other place. Hence, they do not collect at one particular place. For example, you would never hear of excessive smog formation in Delhi during the months of summer. But when winter sets in, a different situation plays out. But what happens during the months of September, October, November, December? During these months, sun is somewhere around here. Northern hemisphere will receive minimum heat and minimum sunlight. During the daytime, what is happening is, this is the surface of the earth. During the daytime, the amount of heat which is coming to the surface of the earth is actually very low. So total heat received by the earth is low. So the total heat emitted by the earth will also be low, right? Let's talk hour by hour situation. For example, let's talk about what happens during 4 p.m. So by 4 p.m., earth has emitted back, let's say 60% of the energy or heat it received from the sun. But as the time passes, let's say now we are talking about 8 p.m. By 8 p.m., there is perceptible drop in temperature of the earth's surface, right? But as we go to, let's say, 11 p.m., the temperature drops even more. Now earth has emitted back 75% of radiations that it received from the sun during the daytime. Now let's go to 3 a.m. in the morning. Now earth has emitted back 95% of the heat that it received from the sun. Now only 5% is remaining, meaning the surface of earth is becoming cooler and cooler. Now let's go to 6 a.m. What happens at 6 a.m.? At 6 a.m., earth has emitted back almost 100% of the energy that it had received from the sun during the daytime. Now, because of this continuous emission of long wave radiations for whole night, the earth has become very cool. Maybe the temperature of the surface of the earth has dropped to, let's say, 10 degrees centigrade during the month of October, or first week of November, right? Now this is 10 degrees centigrade. Now let us understand what happens after that. If the temperature of the surface of the earth drops to 10 degrees centigrade, the air which is coming in touch with this surface will also acquire the temperature of 10 degrees centigrade, right? But the wind which was above will not be 10 degrees centigrade. So the surface of the earth is 10 degrees centigrade. The layer of the air which is in touch with this surface will also be 10 degrees centigrade because it will acquire its temperature from the surface of the earth. But the layer which is higher above will not be 10 degrees centigrade, but maybe it is 15 degrees centigrade. Why? Because this is not in touch with this cold layer of surface of the earth. The layer above is at 15 degrees centigrade. The layer in touch with the surface of the earth is at 10 degrees centigrade. Now tell me what happens. This layer is lighter, right? Because it is warmer. Warm air expands and becomes lighter as we just studied. So this layer will be heavier compared to this layer. So tell me whether this layer will go up or not. Obviously, heavier layer will settle down rather than going up. So heavier layer will be at the bottom rather than going up. Lighter layer will remain at the top because it is lighter compared to this layer. Now, normally in troposphere, what happens? As you go up, temperature decreases, right? Now reverse is happening. As you go up, rather than temperature falling, temperature is increasing from 10 to 15. So this is called as inversion of temperature. That is, normal temperature distribution in the troposphere gets inverted. Rather than temperature decreasing, temperature will increase. This is what happens during winters. Now, because of inversion of temperature, what happens? Normally, as we have discussed, there is a dispersion of pollutants in summer because the convection happens, right? But in inversion of temperature, convection will not happen. Why? Because at the bottom we have denser and heavier layer, at the top we have lighter layer. Why would heavier layer go up? It will settle down, and this traps the pollutants within the lower layers of the atmosphere. So rather than pollutants getting dispersed because of convection, there is no convection during winters, and pollutants are trapped within the lower layers of the atmosphere. And this is exactly what happens in Delhi during winters.